Okay, section 2.5. Looked like everybody was understanding 2.4, so we're not going to really go back over that and rehash it. But 2.5, we're going to learn more about the addition property, subtraction property, multiplication property, division property, and substitution property. Well, this is the property. We're going to go through these one at a time. You can add the same number to each side of the equation. You've done that before, right? When you've solved for a variable, you've done each one of these. In algebra, we did this, okay? The subtraction property, you can subtract the same number from each equation. What are we doing on those two?
You're just using the number or the letter.
If I have x plus 2 equals 4, am I adding or am I subtracting?
You're adding. You can subtract. 4 minus 2. 4 minus 2 equals 4.
See, I don't agree with what they say right here.
4 minus 2 goes the other way.
They're what? All right.
Trevor's just a naughty boy.
If you take a look at what they're doing here, they're adding a number to both sides. So we're looking at this backwards of what we did before. They said if x equals 2, and we add 2 to both sides, then x is going to be plus 2 equals 4. So they're going backwards of what I taught you last year was solving for the equation, okay? That's called the addition property. So if we go from x equals 2 to x plus 2 equals 4, we've added 2 to both sides. All right? The same works with subtraction. We start off with y equals 8, and we subtract 3 from both sides. Y minus 3, and then 8 minus 3 is 5. That's a subtraction property. Okay? We subtracted 3 from both sides. Right, Casey? You understand what we're doing here? Because you're not watching. You're writing on your paper. Casey, come on right up here, hon. Let's go. I want you right here. Okay. Multiplication property. We start out with z equals 2. And we're going to multiply. We're going to multiply both sides by 5. Okay? So what do I have, Case? Look at here once. I'm going to multiply both sides by 5. This is the multiplication property. So we're going to make this 5z equals 10, right? Right? We multiplied both sides by 5. That's the multiplication property. Let's take a look at the division property. 6m equals 12. This is what we would typically do, right? We would divide both sides by 6 now, right? To find out what m is. If we divide both sides by 6, m would equal 2. That's the division property. We're dividing both sides. And the last one, the substitution property. You exchange a part of an expression with an equivalent value. So in this case here, we have 3x plus 5 equals 3. We're going to exchange, and we say here x equals 2. The substitution property is we're putting the 2 in for the x right here. We're substituting that out. Yeah. We're substituting that out, so we have 3 times 2 plus 5 equals 3. Okay, so you understand, you get a little bit of an understanding of how these properties work, each one of them, right? So let's take a look here once. Let's take a look at number 1. Number 1, we're given 6x plus 2 equals 10, right? Or 12. The conclusion is 6x equals 10. What did we do? Subtracted 2. So what property do we use? Subtraction. Number 2, angle 1, the measurement angle 1 plus the measurement of angle 2 equals 90. The conclusion is that the measurement of angle 1 equals 90 minus the measurement of angle 2. What did we do? Another subtraction property, right? We subtracted. Do you see how we get those? You guys are going to have 3, 4, 5, 6, 7, and 8 to do. Don't worry about number 9. Nope. I heard more complaining and whining. All right. Reflex property. We're jumping into some more properties here. In this case here, reflex property. What's happening on this? It's equal to itself. Any value is equal to itself. 3 equals 3. AB equals AB. That's the reflex property. The reflexive property, or I should say reflexive property, of equality, the reflexive property of congruency. When two things are congruent, what does it mean? If two things are congruent, what does it mean? They're the same. They're equal, right? In congruency, we use congruency when we talk about angles. All right? We talk about angles. It's a geometric term, okay? When we're talking about angles, we use congruency. Symmetric property of equality. In other words, if I say Megan and Amber are the same height, okay? I say Megan is the same height as Amber, and Amber is the same height as Megan. Okay, I've gone both ways. In this case here, XY equals ZA, then that doesn't sound right, sorry. ZA equals XY. Yeah, I was hoping nobody caught that. Thanks a lot, girls. I go both ways. No, not really. Dude, that's on YouTube too. All right. No, I really don't. So we're going to edit that part out, and I have the ability. All right. So symmetric property means that when one is equal to the other, all right, and then you can switch it around to say the other is equal to the first one. Symmetric property of congruency. What's congruency again? No. What's congruency? What's congruency, Cade? Come on, Cade. Cade. Congruence. They're the same. They're equal. Yeah. Congruency. Congruency means they're equal. We use it as a geometric term. All right. I know. I saw you jump. All right. So, in this case, angle Q is congruent to angle R, which means they are equal, right? Then angle R is congruent to angle Q, right? Yep. All right. Transitive property of equality. If KL equals MN and MN equals TR, then KL equals TR. All right? How does that work? It works like this. Katie is the same height as Casey, is the same height as Trevor. Okay, so Katie is the same height as Kaylee, right? Katie's the same height as Kaylee? Casey? Oh, Casey, that's right. Katie and Casey are the same height. And we know that Casey and Trevor are the same height. So Katie and Trevor are the same height.
So they're all the same height. It's all the same.
Right. And that is the transitive property of equality. The transitive property of congruency. The angle of Cade's nose, it's a 30, 60, 90, is the same angle as this up here. All right. Mannequin is the same angle as my little mask, right? Nose. So I can say that Cade's nose is at the same angle as my little mask. Right? It's all geometric. We're gonna put an angle to that sucker.
No, we did. Me and Trevor measured.
Did you? You measured it?
Like 2 inches or something like that. Put it on the head.
Well, you guys are funny. All right. I think it was yesterday. All right. Here we go. All right. So match the property to the appropriate statement. We're talking congruency here. So we look at what? Damien. What are we looking at on number 10? The line RT is congruent to the line RT. What is this? What one would that be? Well, we got to take a look. What are the congruency ones in here? This one is a congruency, this one's a congruency, and this is a congruency. Reflective property. All right? Right? It's reflective property. See how we do this? You guys have these to do on here. Hate it when that happens. All right. You guys have these 10 to do. Actually, 16, don't worry about 16. Do 10 through 15 on this page. 10 through 15 on this page. And do the other ones on the other page. That's cool. That means, what are you going to do here instead of talk? What are you going to do besides talk, Cade? You're going to work because what did you get on this last assignment? Uh-huh.